Hello everyone, today we will talk about .NET Source Generators. A few words about me. I'm a senior .NET developer at DataArt, a Microsoft MVP. Many may already know me from .NET MAUI community as I am one of the .NET MAUI community toolkit core maintainers. You can also find interesting videos and publications on my website, LinkedIn, and YouTube. So let's talk about source generators. Source generators were introduced with .NET 5 as a feature of Roslyn compiler. Their main task, as can be seen from the diagram, is the analysis and generation of code that occurs at the compilation stage, which makes it possible to add source code to the project automatically. Today, there are three general approaches to inspecting user code and generating code based on this analysis: runtime reflection, MS-build task juggling, when the same MS-build task can be called multiple times, and IL waiving, when direct modification of IL code is required. Source generators can improve each approach. With the emergence of source generators, they were most often created in dependency injection tasks for automatic generation instead of assembly scanning, for automating mappers, for automatic mapping of properties in enum, when a static class with all the possible methods was generated, and many others. You can find many samples in the following link. Let's consider the work of source generators using specific examples. So let's start from the problem that we want to solve. So assume we have a DB context, we have a program, we have some entity client with some properties, and we want to track all changes that's made for this entity. So for example, when user create, when user update or delete this data. So for that, we use entity framework core. We have DB context. We create client, we edit, we save it, then we update it, also save changes, and we want to save all of these changes to the database. So for that, entity framework has a embedded tool. It calls temporal table. So it is solution out of the box, but it will track, first of all, it will track all changes. It will save them to a specific table. Also, we want to only, for example, save some specific properties, or we want to add additional information, for example, what user made changes, when that changes happened, or other any other information. And with the temporal table, you will only save the same data, the same property, the same properties that you have in your entity. So our next step, our next solution for the problem was to use auto history library. So it's called entity framework or data auto history. As for configuration, it now has enable auto history method that where we need to specify where we want to store it. We need to inherit from auto history base class, and in that custom class we can specify additional properties that we want to store in our for our tracking. So the same here, and when we override save changes for DB context, we can specify that we want to set somehow and get user, for example, and store that information in database. And also it allows us to exclude some properties from tracking. But unfortunately, that solution also was not enough for us because we want to explicitly specify what entities we want to track and maybe add some additional configuration in one place, not in DB context. So for that, we continue researching and found another library. It's called Audit Entity Framework Core. It's really powerful library with a lot of configurations. So for the changes, now to make this library work, first of all, we need to add interceptor, to audit save changes interceptor, and also for each property, for each entity that we have and we want to track, we need to create another table. For example, for client, we want to create audit client, and it will store all information for properties that you need there. For example, let's take a look at our audit client. So we duplicate all properties that we want to save with additional, for example, action type for create, update, or delete, user ID, and when this action happens. Also, for in our program CS file, we needed additional configuration, so we need to configure this library. So in this case, we say that we use configuration for entity framework. We use this DB context and also specify that we use mapper and define how we will map our entity to audit entity with additional configuration for some properties. So that solution worked for us, but until we started adding additional auditable entities. So assume you now have 10 10 entities that you want to track, or you need some additional different configurations for them. And that solution started to have a lot of duplicated code for each entity, and we wanted to avoid that. So we found that we can use source generators to automate this process. So let's take a look at our solution. So let's first start with our DB context. So now you can see that our client DB context is partial class. Also, we do not need to have additional DB set here. So we have only entities that related to our real client DB context. So we do not need to add additional auditable DB sets here. All other settings remain the same. And also for client, we now have this audit attribute. And for all entities that we want to track, in this case, it's client 1 and client 2. And also let's take a look at program CS. So we have the same configuration, but now we have this abstract auditable class that have all common properties for each entity. And also we have this magic map auditables method. And where do they come from? They are generated by source generators. And let's take a look at these classes. So I prefer to use Rider when working with source generators, but the same functionality available in Visual Studio. in dependencies analyzers, you will find source generators there. But in Rider, you can find dependencies and it has explicit source generators folder. So let's take a look at this folder and what do we have here. So we have this auditable attribute. We have auditable abstract class with all properties that we want to additionally track. We have this magic client auditable class. We have configuration for entity framework. We have some extension method map auditables that define all all mappers for each entity. And also we have a partial class for client DB context where we have our DB sets. So how do they actually generate it? Let's take a look at source generator code. So there are two types of source generators. The first one and the first version appeared with .NET 5. It called just source generator. In that case, you need to inherit from iSource generator interface, add generator attribute, and as you can see, Rider already underscore and warn me about using iSource generator, just because it's, let's say, not recommended way to create source generators. Recommended way is using incremental source generators. But just to provide you some idea how it actually works, let's take a look at this implementation. So in iSource generators, there were two methods, initialize and execute. On initialize method, you register what you register for syntax notification. So when some changes happen in your code, when you start typing, it will execute it and create a new target type tracker. In this case, it will search for all, it will go through all your solution, and for each type declaration syntax, it will find node with decorated attribute, in our case, audit. So we wanted to search for audit attribute, and we store these auditable types in some immutable list here. So in this list, we will have all types that actually we need to track. Let's say, so in our case, it's client and client 2, right? Client and client 2. The next step in our source generator is executing. So for execution, we first of all, in our case, we generate two classes. One for auditable attribute and the second one for auditable base class. And we can generate them from just string code, right? So here we have a string code that represents our auditable attribute and also audit class that represents the class with all auditable properties. And when we add these strings to the context source, source generator, when executed, it will save these files to the file system. And as you can see, we have these two files, audit attributes and auditable. Then our next task is to search for all auditable types and go through them and generate a code for them. So for our auditable types, we already found client and client 2. So for them, we generated a source code from text, and this text is written by us in getAuditable class. And in our getAuditable class code method, we want to generate our partial class for auditable. So for that, we create code builder. as a string builder. We find namespace for our entities. We generate a name that represents name of our real entity, for example, client, and append auditable. So it will be generated class name will be like client auditable. Also define all namespaces, all usings that are required, and for each property that we have in this client class, we add it in the list of properties and generate it as getSet attribute. So the next step is generating configuration for entity framework. The same applies as a partial class for generated class name client auditable, and we define identifier for it. The next step is generating DB context, where we define it as a partial class client DB context. We add DB set for it, and also we define our auditable model creating method, where we specify each configuration that we have for each type that we generate. The next step is generating map auditables, and we create the static extension method where we call map for our original class name client and generated class name like client auditable. The final step that we need in our generator is just to store this information and edit the context source. That's it for source generators, and everything worked fine. But why do we have incremental source generator? The problem with source generators that each time that we change some information, for example, let's take a look, client 2, last time generated at this time. And for example, let's update some property as statuses. And let's take a look at client 2. It's updated at the new time, but you can see the same happened for client auditable, DB context, auditable attributes, extension method. So all our classes were regenerated again. And for example, we update client 3 as well and add statuses. And let's take a look. Our time, as you can see, changed again. And that is a problem. It changed even for entities that we do not want to track. And that is the main issue of source generators. Assume you have a big solution, a big project with a lot of classes, and it takes time to analyze all your classes and also regenerate each file for you. And incremental source generators should fix this issue. Let's take a look at incremental source generators project. There are no differences in our original file. And as for incremental source generators, first of all, let's take a look at our CS project file. It's a .NET Standard project. We also need to package references for Microsoft Code Analysis Analyzers and Code Analysis C#. And we want to also ensure that library will be packed as a source generator when we use .NET Pack. As for dependency for our project, we want to specify it as a project reference for source generators. And important part that we need to set a target framework because source generators are only .NET Standard projects. And also we need to specify that output item type is analyzer, and we do not want to reference it as an output assembly because source generators are only for build time. And if you want to see generated files, we can edit this compiler generated files output path, and all files will be generated in this folder. And let's take a look at our generated files here. They are the same as with original source generator. And what are the changes of incremental source generators and how do they solve the issue? Let's take a look at generator file first. So first of all, it's a new interface, incremental generator, and it only has one initialize method that we need to implement. What are the changes here? So first of all, we register post-initialization output. So when source generator is initialized, we will generate and add to source our attribute and auditable files. Declaration of code is the same. The next is our um, auditable types to generate. So we want to get and search for in our context syntax provider. We want to search for entities with specific attributes. So in incremental source generator, there is a very useful method for attribute with metadata name. It's commonly used because mostly we find something that we want to find by attribute. So in this case, we search for attribute, audit attribute. We search for node, and we transform it in get type to generate. So here we get each type that we found, and for it we get its members. We find if it's property, and we store this property in this list. Later we return a new audit to generate read-only record struct. First, why we choose this type? Just because record it's immutable and also implements equitable interface, and it's very important for us for caching. I will show you why that it's important on future slides. So when we generated this class, when we store all information like name of our entity like client, we store its namespace and all properties. We now back to our source generator, and the next step is executing all data that we found. So register source output. So for all auditable types to generate, we call execute method that just generate a code for us based on information that we provided here from audit to generate class. And what do we have here? So we have the same string builder where we specify all usings, specify all attributes, all properties. So implementation of source generation helper class where we generate code is pretty much the same. The only difference is now we get information not like from properties or symbols from from our code, but already found it and get it from stored information in our record. So after we found that information for all our classes, the next step is we want to also register implementation source output for our DB context, audit mapping extensions, and generate also information for them. And that's pretty much it for incremental source generators. It was the only difference from source generators. And let's now take a look at how it works. So, for example, for client, let's take a look at the time. It's 12:18 p.m. Client 2 should be the same time. Great. And let's now update our client. Let's say statuses. And let's take a look at the time. You can see time changed. And if we go to client 2, you can see the time remains the same. So client 2 file was not regenerated, and that's what we actually want to achieve. If we take a look at DB context, for example, the time also remains the same because we didn't regenerate client to client 2. But for example, if we go to client 3 and add audit attribute, let's give it some time. You can see client 3 appeared here, and our client DB context time updated with adding all configurations, added configuration for entity framework, DB set. If we take a look at auditable audit mapping extensions, you can see client 3 appeared here, and that's pretty much it for incremental source generators. Now back to our presentation. So in source generators, cacheability is the most important factor. Let's see how it works. So assume we have an enum with two values, first and second, and we have attribute enum extensions. On the first execution, all of the stages executed and the intermediate results are cached. So for attribute with metadata name, we will find all symbols that need to be analyzed. Then we select them and values to generate. Output the new sources generated and added to the output. Then the user added their code adding an unrelated class. The first stage executes, but it produces the same output as the first run. So, as the input are the same, the next stage is skipped, as it can be used the cached outputs. Similarly, generation can be skipped because the output are the same. The user, on the next step, the user edits their code, adding a new enum value. In this case, it's third. So, the first stage executes, but this time produces different outputs. As the input is different, the next stage must execute and produce different output. So our code is regenerated. Another sample that I want to show you is a credit card validation. So let's take a look what do we have here. Let's say benchmark service. So for this specific sample, I created a benchmark. So what do we have here? We have a big data CSV file that has a lot of properties. Some properties has credit cards. Some of them do not have credit cards. We have 20 properties, and some of them are common for one model, and some models have different properties. So we want to map them to this class. We have a base model. We have 10 properties here. Some of them we want to validate with credit card. Some of them, like property 10, should be skipped during validation. Also, we have model 1 with property 11 till 15. And we have model 2 with property 16 till 20. And we need to map this CSV file to this model and check properties that have credit cards and provide the list of like errors that this specific class, this specific property contains credit card. So first of all, we need to read this CSV file. We use CSV reader. We registered two mappers for model 1 and model 2 for each property. So you can see common properties, 10 properties, and specific properties for model 1 and for model 2. After this registration, we start reading, read headers, and start reading the content based on a value in property 16. We define if it's empty, we understand that it's model 1, otherwise it's model 2. So we read this file, and now we have two methods: validate credit cards and source generator credit cards. Let's take a look at first implementation. It uses reflection because we do not know actually what value do we have in this list. We have a base model and the property list different. So for each item in this list, we need to get its type, get its properties, find custom properties, and check if a specific property contains this attribute. So because this list is dynamic, I mean that it can has model 1, 2, 3, whatever, we cannot like predefine what types or what properties we will get for specific one. So we can not cache this information and calculate only once. So for each model that we received here, for each property, we get its value by reflection, and we use credit card validator just to validate if it contains credit card or not. And if it contains credit card, we also provide the row number that contains this error, and also return property name in uppercase. So for each row that we found, we need to return property name in uppercase and of course its value, and return results. So reflection is slow, and we somehow want to avoid using reflection. Also, you can see that this code you executed each time. Also, we generate additional string each time for each row that we, for each cell that we found with credit card. We need to update the name of the property to upper case, and it allocates additional memory. So how do we solve this with using source generators? Let's take a look first on implementation, and then we'll see what this actually generated. So in this case, we already, using source generator, we can define a list of properties that contains credit card validation. So in this case, we return a enumerable of property value, where property value actually contains a list of property name and property value, and we iterate over it. So let's take a look what is inside this method. So it's an abstract method, and if you want to look at implementation, we can see that it exists in model 1 and model 2, and both implementations generated using source generator. And you can see what is inside. So for each of them, we have property value with the property name already in uppercase. So we do not need to regenerate it each time. So this property is already in correct case. And also we get its value. As you can see, property 10 didn't have attribute validate credit card, so it's skipped in this list. So when we call this method, we already know the valid list of all properties and property names and property values that we need to validate during credit card validation. And now let's take a look at how this source generator actually created. So we have model generator. It's also an incremental generator. First of all, we register property value class for us. So get property value code method just returns a record of property value with a string property and string value. And the next step is our syntax provider. So we return, and first of all, we are looking for all classes that has a base type where it's type a base model. So in our case, it's this class. So we want to find all childs of this base model, in this case, model 1 and model 2. When we found it, we call get type to generate transform method. And in this method, we check if it's a name symbol and we get all its members and all members of its base class. In this list, we check if it's a property and also looking for all attributes that has this validate credit card attribute name and generate a property array for our class to generate. Class to generate is pretty familiar from the previous sample. It also contains the name of our class, like model 1 and model 2, its namespace, and of course list of properties that needs to be generated. And if we take a look at source generation helper, that is executed after we found necessary classes, we get for all properties, we generate this return. And we already define property in upper invariant case, so we do not need to execute this code during runtime. It will already generate it for you at the build time. And as a result, we generate this partial class for our case model 1 and override this abstract method from a base model class. And it will contain all necessary code for each property. That's it for this sample. And if we take a look at program, then we execute two benchmarks. We execute two methods in our benchmark to just see the results. Let's take a look at them. So from benchmark results, we can see that source generator implementation executes almost 4 times faster than the original validate credit cards method and also allocates 2 times less memory than the original method. There are quite a few alternatives to source generators, but the main ones that most people know about are FIFO, Scripty, and FODI. For myself, I signed down the following advantages of source generators. The first one is that we no need to learn new syntax. The second one, source generators are part of the compile pipeline, so they work wherever the compiler works. And the third one, that we do not allow to rewrite code. The only significant drawback, in my opinion, is the limitation in the generation of file types. Source generators only allow to generate C#, F#, or Visual Basic files. So let's take a look how we can bypass this limitation and generate whatever files type we need. So I'm developing a cross-platform plugin system called Draw and Go. It's a system for automating your routine tasks or just automating your usually routines. So let's take a look how I bypassed the problem with source generators and generated file type that I needed. So I have for my program, I defined the base class macro command that defines some plugin system. In each plugin, we may have a lot of macro commands. So in this case, macro command called start. It has some properties. Also, it has expert attribute that defines this macro command. So it has a name, category, description, and platform on which this macro command can be executed. So, first of all, I tried to implement the source generator for it, and I found that it cannot generate me a JSON file. So I wanted to generate a plugins JSON file that contains all information for me. So like type, name, description, platform, some links and values. So when my program is running, I do not want to use reflection to read all and find all macro commands at runtime. I just want to read the plugins JSON file that as for my scenario is more is faster way to load all extensions and find all extensions there. So how this plugin JSON file is generated? For that, I use MS-Build plugin. Let's take a look how it's connected. So it's just an NuGet package, and it's connected as a package reference. Also, let's take a look at MS-Build. So what do we have here? First of all, let's take a look at CSproj file. As you can see, it's an executable file. All other information is required for NuGet package. Also, I have package reference for MS-Build utility score, code analysis C#. Also, I add additional targets. So when my when MS-Build task is executed, it will include this MS-Build targets and put it in package path. Also added README file. As well, I reference additional project that is required for MS-Build, for my MS-Build task. And also I copy project references to package. And let's now take a look at this program CS file. What do we have here? So idea is pretty simple. We use string builder just to generate this JSON file and what is inside of it. So the main idea and the main method that is executed is parse and generate. So we get a compilation. So what is inside? So for my project that references this MS-Build plugin. And this MS-Build plugin is executed in that environment in the same project that is referenced in its base directory. So in that base directory, I am looking for all CS files. So because I am using C#, so I'm looking for all CS files. Then I read these files. For each file, I search that it contains macro command. So in that case, I understand that my file is actually plugin file. for my macro command, I parse this file using C# syntax tree parser, and I return syntax trees. After that, I need to load additional libraries. In that case, I load base core assembly. Also, I need to load system runtime, and also I need to load export attribute. That is why I need to reference the base project where its export attribute exists. And all that syntax trees are compiled into dynamic link library called temp compilation. After that, syntax will be pretty familiar what we had in source generators. So for each compilation syntax trees, I can get semantic model for this tree. I find the root, so it's a base class. I find the send nodes, class nodes, and for each class, I'm already starting working for all attributes that I need. I build properties, I build some links, so I continue starting building all my logic that is required for me for specific. Also, I'm building for values, links, properties in my plugins JSON. And at the end, I just write this plugins JSON with all content. That is the base idea of generating a JSON file. In my case, you can generate whatever file you need. You can write whatever files you need in that case. And let's also take a look at that targets file. Target, so it's actually a project targets file, and the target task for MS build. So MS build is executed by tasks, and it executed like a middleware. So we have generate plugins JSON target that is executed before build. So just before actually build started, we generating our plugins JSON because we want this plugins JSON included as a content in our output directory. So we execute our MS build file, and after this execution, it includes this plugins JSON, and finally we write the message that the JSON file was generated. If we want to clean this project, will be executed as after clean, and we just delete file. As you can see, I cleaned, file is deleted. Let's now build it again, and you can see that our file is generated. You can see that we received successfully created package. It also included and executed our MS build task for this project, and returns the content of our JSON file. And we see that generated plugins JSON, it's this message, and then it's generated a package for this project. That's it. We can take a look again at plugins JSON, and this is how it's generated. That's it, how you can bypass limitation of source generators generating only C#, F#, and Visual Basic files. And let's back to our presentation. Useful links and samples can be found on these websites. This is the end of my presentation. Thank you for your attention.